All right, here we want to show the distance between two skew lines, which have got the equations r is equal to a plus lambda b, and r is equal to c plus mu d, where of course lambda and mu are scalars. So we want to show that the formula, which is the shortest distance, is given by this form. So it is important that you understand before you do anything that what are skew lines, or how do they look like. First of all, these are lines that are not parallel. Then secondly, they don't intersect. So this is the definition that can guide us what are skew lines. So if we look at the diagram 1, we've got two planes that are parallel, which suggests that the distance between them is constant. So if you carefully look, there is a yellow line there, which is a line that is starting from line 1, which is on plane 1, to line 2, which is on plane 2. This yellow line is what we call the shortest distance between these two skew lines. So this is the shortest distance between these two skew lines. And you can see again that this line, it is perpendicular to the parallel planes. So in order for us to find the equation that represents this line, we can use what we call the cross product, because this line, which is in yellow, it is perpendicular to the line number 1, which is on the first plane, and then perpendicular to line number 2, which is on the second plane. So should I call this line F? In fact, let me call it E. It means this yellow line here, which is our shortest distance. So this is our shortest distance. And we are calling it E, is actually equal to the cross product of the two lines, line 1 and line 2. So the cross product is B cross D, because the cross product is actually a vector that is both perpendicular to B and perpendicular to D. Hence is the yellow line, which is the shortest distance. So if you look now on diagram number 2, if you turn the diagram a little bit further, if I create another line, in this case, a line that is starting from line number 2, the black line, and I've called that point Q, and I've taken that line straight up to the plane above, you will see that this blue line is the same distance with this yellow line, because there is distance between the two planes. Then if I make another point, so we can actually say the yellow line here is E, and it is the same here as E. So if I make another point on the red line, the line number 2, and I call that F, what it means is we have created a triangle that looks like this. We have created a triangle that looks like this. It looks like this. Where we've acknowledged already that this is E, is the same as E. And the angle between this E and the line QF, we call it theta. So our QF can be found because it is between these 2 points. It is a line, it is a vector equation that is between the two lines, which is line 1 and line 2. So it can be found by saying QF in this case QF is, we are going to subtract these two, so it's going to be A plus lambda B minus in brackets C plus mu D, which can be simplified as A minus C plus lambda B minus mu D. That's QF. Okay, now doing some trigonometry, basic trigonometry here tells us that cos theta, because if we want to make E the subject of the formula, cos theta, because it's adjacent over hypotenuse, is going to be E divided by QF. So this obviously implies that E is equal to QF, which I'm going to write as the modulus of A minus C plus lambda B minus mu D cos theta. The reason why I'm putting the modulus is because when I'm using this trig ratio, I'm actually referring to the length, the actual length, which is the magnitude. So since this is a vector, the magnitude of this vector is just the modulus of that vector, cos theta. And we know very well that if I choose to multiply this with 1, an extra 1, the modulus of 1, nothing changes with this the equation. However, I can manipulate this 1 and in terms of E, because I already have the vector E, which is in the form of B cross D. So if I look for E, let me just do it here aside. If I look for E, unit vector of E, which is equivalent to 1, real quickly, yeah? So we can say 1, our 1 here is equivalent to the unit vector of E, which is basically B cross D all over the modulus of B cross D, like this. So E, which is our 1, can actually be written as, so we are going to have A minus C plus lambda B minus mu D, then E modulus of E cos theta. All right, now taking this, if you go back to first book of vectors, we said A dot B is the same as A magnitude of A times magnitude of B cos theta. So if you look at this formula right here, it is actually the same as that, which takes us to say E is equal to the magnitude of this vector, which is the same as saying E is actually equal to A dot B, which is going to be this vector dot this vector. So it's going to be A minus C plus lambda B minus mu D in brackets, then dot B cross D over B, the magnitude of B, like this. That's our E, looking at it, because the E, the unit vector, this stands for unit vector, which is 1, which has got a modulus of 1, a magnitude of 1, can be given like this. D is the cross product of D times D. So this is what we have now. You can distribute your formula using the distributive property. So you can actually use the distributive property here. You're going to have A minus C dot B times D magnitude of B cross D plus lambda B dot B cross D over the magnitude of B times D minus mu D dot B cross D over the magnitude of B times D. So this is what we call the distributive property. the distributive property. So it's basically you're just multiplying this quantity with everything that's inside the bracket. But what is it that we can remember from the associative properties of the dot and the cross product? We remember that B dot B cross D is equal to 0, which further suggests that D dot B cross D will also be equal to 0. Okay, so what does this mean? This whole part here is going to be equal to 0, and this whole part here is also going to be equal to 0. So as a result, E is just E minus C dot B cross D all over the magnitude of B times D. However, since E is distance, it's a scalar quantity, it has got to be positive. That means we have to write it in full like this: A minus C dot B cross D all over B cross D, then with a modular sign here, as required above. So that's how you can solve this formula.